Welcome everyone. This is the Dualtron charger, the Dualtron Mini's charger at least. In this video we are going to talk about the charging of the Dualtron Mini and some tricks that I want to use for myself. We are going to mess with the electric circuit of the charging, so don't do this at home. Be careful really, because the output of this charger is about 60 watts, so this can be dangerous. So there is two things about this charger and the way how you can charge the Dualtron Mini that I would like to obey. The one is that at the dealer shop they told me to first connect the charger to the mains outlet and then connect to the scooter, not the other way. Because when you connect the charger, there could be, and actually there is, some voltage spike coming out of it, and that is able to damage the internal circuit of the scooter. I would like to be careful with that, but this means that when I come home, I cannot just connect everything up and turn on the switch to charge the scooter. I need to plug it in first and then plug the scooter in. This is a little bit of a hassle, and I'm lazy and I would like to automate actually everything if I could. In the manual we are informed here that this sparking thing can happen and that this is normal. Still, I would like to be on the safe side, so I would like to connect first the charger and then the scooter. The other thing is, on the next page actually, it says that in case of moving from cold outside to warm indoor, please charge it after 1 or 2 hours. This is to prevent condensation from occurring inside the product due to temperature difference. So, in the colder weather, I need to wait for 1 or 2 hours to be on the safe side with the scooter. And actually this is conflicting with the first, in a way that if I'm lazy and I would like to use a timer switch to set it up for 2 hours, plug it in and then go around with my business, I cannot do that, because this will turn on the charger and then as it is plugged to the scooter, the voltage spike will go into the scooter itself. So this is the problem we were going to talk about in this video, so stay tuned. Let me tell you about the first way I tried to solve this problem. I was like, okay, I cannot connect the scooter first, but this is like 58.1 volts. I can just make a switch to delay the switching on in the charging side. So I can connect the charger as long as I want and when I want. I can put here a timer switch and then how good it will be. And it will actually solve both problems. I can turn it on a little bit later to avoid the voltage spike that is happening when you connect the charger. And also I could set it for 2 hours and then it will turn on after 2 hours. So let me show you my first attempt with this. I bought these connectors. They are called GX16, by the way. I figured out the connections in the charging plug and I bought this Chinese timer switch. With this I can set it for like a short period of time. I can connect the charger meanwhile, or if I'm coming from cold weather outside, then I can set it to 2 hours, like that. And then in 2 hours it will start to charge. And I don't need to keep track of time when I arrived and when I need to plug in the scooter. I don't forget it. So I thought how good of an idea this is. Out of the box, this timer caused me some problem, because this is for opposite reason that I need it to. So this is turning the switch on only during the amount of time I'm setting here. So this is normally on only for this amount of time. And I needed the exact opposite of that. I needed normally open connection, which only closes when the timer is off. I mean, it doesn't ticking anymore, you mean. So I needed to mess around with that a little bit. This is not really nice, but I think it is fun, so let me show you. Originally there was 2 connectors inside. There was a little switch inside which was moving up and down, and as you can see, if I trigger the timer, or I'm not sure the correct word, so when I set it, then it comes up, and there was a second connector inside, and this is how it was closing the circuit. This is really troubling that people would use this with mains, because it was really sketchy. So what I did was I added this wire and I added these 2 micro switches And this way I can switch the two poles together. When I set it, it presses down. So this is how the switching action is going on. It is already way more complicated and took way more time than I anticipated, but I thought at least, okay, it will work. But turns out this is completely wrong. Because the charger has some inside logic for battery and user protection. I can argue that it might be good, but still I'm not happy because that crossed my idea. So the thing is that this plug has 3 connections. 1, 2, 3. There is small labels. Yeah, there you go. 3 to 1. So as far as I know, 1 is positive, 3 is negative, and 2 is not connected. So this is the GX16 connector. But let me show you how this is working. Okay, so let us have this connection right there. So when I turn on the charger, we are getting our almost 60 watts. Now I'm going to wait like a minute or so and let's see what happens. So there you go. I did not touch anything. About a minute passed and the charger is still green, but now it doesn't output any voltage. And actually it will not do any charging at all until I turn it off and on again. If I'm connecting the charger to the mains outlet and I'm not connecting it to the scooter in 1 minute, then this will turn off the output and then I cannot charge. So imagine if I would set a 2-hour timer on this line, but after a minute there is no voltage at all, so that is useless. And I cannot turn on the charger, the mains timer switch, because that might probably cause harm to the scooter. So that's trouble when you are lazy and you would like to automate this out. So let's put all this away and let's see what is my plan to solve this problem. Here comes in for our rescue this circuit, which is a delay relay, as it is called. And actually it is programmable. What is it doing is that you supply it 12 volts and you can program it how to function, but basically you can set a delay and it will turn this relay on after a set amount of time. This is the basic function that we will use. It can be used in several different ways, like you can trigger it and you can delay the turning off and so on. I will link this circuit in the video's description. So, as I have told you, this is working out of 12 volts, but we have almost 60 watts here. So the solution for that is a simple DC-DC converter. This is a cool device. It can accept from 30 to 90 watts, anything between, and the output will be 12 volts. And actually it can supply 3 amperes. This is one solid block. You have 4 wires, 2 in, 2 out. I have a nice box. I'm planning to install all this inside. So what I'm going to do is set this up in a way to wait like 10 seconds and afterwards close the relay. So just to recap how it's working, this is the simple drawing. I'm no electrician and don't kill me for my circuit diagram, but you have the mains, you have the power supply, you have your connection, this one, and you have the scooter. So this is the normal way. And without any trickery, you need to connect the PSU first and then the scooter second. And this is what we are messing about. So this is my plan how to automate the charging of my scooter. As you can see, I have the mains here. I have the option to add the mains timer to the charger. And then I will connect to the output of the power supply unit this DC-DC converter, which will power my delay relay. And my delay relay, it's a funny word, will turn on the charging output of the charger to the scooter. I'm especially happy about the relay because there is no interfering with the charging line. There are no active components between the scooter and the charger. It is just a switch, which is closed by a magnet. So let's start experimenting with all this. For a test, let's start with DC-DC converter. I have it wired up right here. The input side is the black and red. The outside is the black and the yellow. I have a very small little motor just for a test. And here I have 40 something volts. Let me show you. Yes, I have 40 something volts. This is not the charger's output for now. Because first I started with the charger output and it makes quite a big spark. And I started to think that this is faulty. Actually, it is not. So I should exclude myself with don't do it if you don't know what you are doing part, but let's go on. So if I connect almost 50 watts to this converter, it will make a big spark and then the motor starts to turn. If I let it off, the motor of course stops. And as you have seen, the motor is delayed. So after I disconnect the power, it will still turn a little bit. And this is because of the internal capacitors, and those are the ones who are making this big spark. So our DC-DC converter is working. It is about 5 milliamperes on 50 watts. Now, I have wired up the DC-DC converter to power the delay relay and the meter to measure the switch's state. If it's 1, it's open. If it's 0, it's closed. So let me power it on and see what happens. It starts to count back from 5. Small click, and it is turned on. So out of the factory, it is programmed just to do what we really need right here. But it has 18 different functions and you can program it. So let's see how to do that, even though we don't need it. So if you don't care about programming this, then you can skip this part. I have figured out how to program this thing. There is documentation, but it doesn't really tell you how to program it. So let me show you how to program it. Let's see the buttons first. You have 4 buttons down here. You have set, switch, num plus and num minus. And then you have 5 LEDs. 4 of them are here, but this is when the number of the program is visible on the display, either during execution or when we are in the setting mode. T1 is an amount of time. It's the first amount of time that can be set. T1 is the second, so you can set 2 different time intervals, and depending on the program, they will be used to turn the relay on or off. NX is a counter value. Many programs use this as a limit, like do it only 5 times. Then you have one up here. Let me restart it. Then we have one up here, which is on only if the relay is turned on. So, how to configure it? First of all, you need to find out what kind of program you want to use. Let's say that we would like to use the first one, which was on by default, which only uses T1, and it will delay the timing on by T1 time. And that's it. So the way to enter to the setting mode is to hold down the set button. See? Then the number of the program starts to blink. And with the num plus and minus buttons, you can change the number of the program. Now, let's say we would like to set the 10th program. Then you need to set this digit to 0 and then use the switch button to switch between the digits. Like this. And this is how you set the 10th program. But let's keep it to the first program. So I set the first program and then hit the set button again shortly. Then as you can see, the T1 LED is lit and the number we have here is the value of the T1 delay. So we can set that to anything. Let's set it to 10, which goes by 0 on the first digit and 1 on the second. And then we have T2, which we don't care about because this program doesn't use it. And also we have NX, which is 101 right now, but we don't care about that right now either. So to activate it, just hold down the set again. And that's it. It starts to count back. And then the relay comes on. So that's all about that. I'm going to assemble the whole thing together. Now, I have this old project right here, and I'm going to cut this off. I have removed this wire harness, and I'm going to reuse it for this this project. I have connected the second pin in the plug with this purple wire. I do think this is not used, but still I will connect them together. This is going to be the input side, and this will be the output side. Just like that. That would be much nicer if it would be on the inside. So let's do that. Meanwhile, I've got an idea that since this is short, but this could be put into the box itself. I mean, I could drill a bigger hole. I could just mount it like that. So it would be way more nicer and I would have more wire available. So now this will be the first time I'm using this new drill bit for that. Yes, it is 15 and a half. Yeah, I have 14 and 16. Let's do 16. Well, that was quite fun. So this is now looking very nice, but we have that bars right there. So we need to take those out some way. In some hardly sophisticated way. One's out. No. Yes. There we go. Let's find a screw. So the purple ones are the pin to the second pin. Let's just connect them together permanently forever. Once again, I'm not an electrician, and actually I'm using this Wago connectors for the first time. This video is a first from many angles. First video where I'm building something. This is the first where I used this funky drill bit. And this is the first when I'm using this connector. So right now we have the blue and the brown. And I have no idea which is the positive and negative one. Pin 1 should be the positive, and that is the blue. Very good. So blue is the positive. This is the way it will work. So let's remember our diagram. We want to connect the DC-DC converter to the charger's output. So this is the end of the charger. This will plug in to here. This will be the input side. So from this input, we need to power the DC-DC converter. We need to connect this input to the relay's input. Actually, the delay relay is labeled very nicely. We have in 1, which we don't care about right now. And we have DC minus, DC plus, and this is a 12 volt unit, so we know that we need to supply 12 volt right here. And this DPDT, if I remember well, means double pole, double throw. It means double pole is that we have two wires that are switched, 2 poles that is being switched. We have 2 switches. And double throw, if I remember correctly, means that they have 2 positions. So a single throw would be just a single switch which can turn on or off. But this is a double throw switch which means there is terminals for the normally connected and the normally open sides too. We have here the terminals of the relay. These are galvanically separated from the circuit. So this is just simply a switch. There are no active components between that. So as we can see, we have COM1, which is the common one, and the common terminal is normally closed to the normally closed output. It is normally closed. And there is another terminal which is normally open. That is the default state of the switch, that it is normally open. And right now, the COM1 and normally connected one is connected. But when the switch activates, it will connect to the normally open one. And we have two of these. So we have COM1, COM2. COM1 is to the normally connected one in default state, and COM2 is the normally connected two by default. So what we want is that the input would reach the DC-DC converter, and then it would reach COM1 and COM2. Let's do just that. We have the input positive and negative right here. Let's make this connection. The previous one, this one, I think this is a little bit short. I think the wires should come all the way to the end, but since it is not connected, and even if it would send some signal, it would be not high current. I don't really care about this one, but let's give a little bit more care to this one. So this is the input side. Oh, that's so beautiful. People are using this, I guess, for 15 years, but this is the first time I'm using it, so I'm just happy for this new experience. This is the negative side of the same thing. And as we see, one side should go to the DC-DC converter's input. So the black and the red is the input for the DC-DC converter. If I remember well, the positive was the blue. So the blue one should be the positive. Oh yes. And just plug it off. So the negative is the positive. Oh yes, that was nice. So the blue is the negative. The blue is the positive. Oh my god. So I'm going to connect the positive wire to the blue one. Oh, this is really nice. I really love these connectors. And then I'm going to connect the input sides. The input side's negative connection, which is the pin 3 and the brown wire in my case, to the negative input. This is the first test. Let's power on the charger. Let's see if the delay relay will turn on or not. Oh yes. Now we need to wire up the charger's output to the common connections of the relay. So finally we will have at least two color correct wires in here. So this is the input of the charger, and the blue one is the positive, which is a very sad fact still, but it is what it is. So now this is the positive output of the charger. And this shall connect to, let's see, to the common terminal of the relay's input. So COM1, COM2. So the second from either side. All right, so let's recap what we have already. We have the charger's input connected to the DC-DC converter, and we have connected the DC-DC converter to the delay relay. That is the black and yellow wire. We have connected the charger's input through the COM1 and COM2 inputs of the relay. Now, let's continue. What we need is to connect up the output. So, the blue is the positive according to the output wires. So that will go to the normally open. Quite bad. So, we have actually completed everything which is needed here. We have the input we have the DC-DC converter and the relay on the input. We have the output from the relay, and we have the delay relay right here. So let's check everything before we connect to the scooter. Let's turn on the charger. Let's measure quickly the output right here before the timer sets. Yes, it is 0 volts right now. The timer is about to going off. And we have our 57.9 volts with the correct polarity right there. So 1 is positive, 3 is negative. We have it completed. Let's put everything together. Disconnect the charger. Disconnect this one. Let's add the cable tie right here, just to make it a little bit more resilient to stupidity and accidents. No, it will not going to come out. Now let's tuck all these connections down in there. Let's convince this delay relay about its position too, and then find out that we cannot put the cover on because of the relay, which is too high. So maybe we need to flip this one. All right, as long as I'm holding it, it stays together. Let's put the cover on. Screw in every screw to have something to screw out when we find out what we screwed up. I have tested the setup and my idea, and let me tell you, it doesn't work. So I have here the setup, which I have been talking about all this video. I have the input from a timer. I have the charger, which is connected to our delay relay configuration, which is connected through the extension to the scooter right there. Now, it would be so nice, but the scooter and the charger is way too smart for us, and they outsmarted us. We have several different problems. All right, so let me show you how this is working and actually how this is not working. Let me energize the charger through the timer. Let's say that the time is passed and the charger is on. We have about 10 seconds. And now the relay is on. And now it is charging the scooter. And I can see that it is charging with the voltage indicator on the controller. Now, up until this part, it works as expected. But if I turn the charger off, the relay did not click. So the relay is still on. So what I'm guessing is that when you start to charge the scooter, it will connect you to the battery and it will not disconnect you until you remove, I don't know, the charge. So now the delay relay is still powered, the DC-DC converter is still powered from the scooter itself, not from the charger. Because the scooter senses a load, which is the DC-DC converter, and because of this, I guess, this is all guessing, it does not cut the connection to the battery. So actually now my battery is powering the delay relay, and the battery is still on, and the relay is still on. Let me show you what happens if I disconnect the scooter. Here, it clicked. This is now the relay turned off just now. It doesn't turn back on, so that's why I said that they are smarter than we need them to be. It will not turn on right now. So this is a failure again. I guess I need to power the delay relay from a different power source. And actually that is what I'm going to do. So I was kind of prophetic while I said that let's turn all screws in to have something to get out. Let's do that. So by adding a second power supply, we will still be able to make this work. Still, it's just a little bit painful to use two power input just to alleviate our laziness and to solve this problem. So just to recap, what happened was that both the scooter and both the power supply unit senses the load. The power supply unit is it has a LED which is green if it doesn't charge, and it is red if it is charging. So by measuring the current passing through, it can decide if it is charging the battery still or not. The battery management system can cut off the connection of the scooter from the charging port, therefore signaling that there are no charging is going on anymore. And also the power supply unit is smart enough that once it was charging and once it stopped charging, it will not start again. I think this is a protection thing to avoid, I'm not sure the English name of it, but you know, the continuous charging from 99.9% to 100%, because that is not good for the battery. And also probably for safety, that if you, after you charged your scooter, you unplug the charger port, it will not be energized anymore because it stopped charging. And also we have seen already that there is a time period in which you can connect the load, and if you pass that 1 minute or so, then the power supply unit cuts the power and it will not charge. So the problem is that the scooter does the load sensing also, and as you can see, if we take out the charger, actually the DC-DC converter is connected to the scooter itself. So this is a load, and it is a load big enough to trick the scooter, and when the scooter senses that there is a load, it will connect the output, the charger port, the charging port itself, to the battery. And I think this is a safety thing too, that if you are not charging the scooter, it will not be connected to the battery, so you can avoid short circuits and problems, because you know that charging port is on the side of the scooter down there. It can get wet, it can get snow and all kinds of stuff in it. So this is very good, and actually this is a positive thing with Dualtron. So they were really doing their homework, protect you from yourself and from any kind of mishap, because both sides are measuring if they are receiving current or not, or giving current or not, and they cut off whenever they can. The scooter only connects to the charger if there is a current, and the charger only gives out current for 1 minute, and if you start to use that current, then it will continue to supply the current, and after the battery is charged, the scooter will cut the connection, and then the power supply unit turns to green, and it will not be enabled anymore until you unplug and plug it again. So this is very nice and very good, but not good for us because we have inserted a load between the two. I did not anticipated that they are that smart, and we messed up everything with this. Even if it would work, it would not be a good idea to keep it this way, because the power supply unit thinks that there is a load in it, even if it is just the DC-DC converter. So the power supply unit has no way to determine if the scooter is charged or not, and it will charge it all the time. Probably the scooter is smart enough not to let that happen, but still, we are messing a nicely balanced and protected connection, and we should really not do that. My idea is to add a second power supply for the delay relay. And that way, if we remove this one here, so this is not here anymore, we supply a separate 12 volts into it, then we are not messing with the load, we are not messing with the connection between the two. We are only switching it on and off. It is the same as if I would plug it in or plug it off. We are not adding any more complexity to that. We are adding complexity to ourselves, but we knew that already from the beginning. With all that being said, let's start again. Let's remove the DC-DC converter then, because although it's a nice unit, we don't need that anymore. I'm so thankful for this Wago connectors, because I can just simply open it up. Originally I planned to solder everything here. I have this soldering iron set up right next to me, but I'm so thankful I did not do that. And I have this standard connector. This is for LED strips, and it happens to fit quite nicely together with this one. So let me drill one more hole. I need a 1 centimeter hole, if probably a little bit smaller if I can, and then it will fit snugly. So let's imagine a hole right there. I have my hole drilling right there, and I have found out that these drill bits are really nice because they are first starting to give a nice rounded edge to the hole. And actually I'm going to take advantage of that. See, it had a beautiful nice finish over there. What I did was I used a 9mm drill and I wiggled it around to make it just as big so that I would be able to insert it with strong force. Therefore, it will keep itself in place for our purposes, at least. It will stay that way. There you go. It is quite nicely there. I could hot glue it in there, but I will not bother with that. So let's check the polarity. We have almost 12 volts right there on the spot. So as far as I know, this is a pair of tweezers. This one is a pair of tweezers. How do you call two pair of tweezers? Is it two pair of tweezers? Oh, that's a tongue twister right there. Why am I not using it? Okay. All right. Now, let's see if it is working or not. Let's power up the external power supply. Ta-da! 9, 8, 7, 6, 5, 4, 3, 2, 1. Clock. There we go. So let's turn off the power supply and put everything back again. Now what shall I say to these screws? Let me screw them in for the last time. The final touch, I'm going to label everything. This is 12 volts in, charger input. Let's recap what we just did. So we removed the DC-DC converter and the connection from there, and we added separate 12 volt connection to the delay relay. With this, we made sure that there are no active components on the line. We did not add any more load to the charger or the scooter, and therefore the scooter will not power our DC-DC converter back when things go south. But now we need a separate 12 volt input, and that's what we added just now. Let's see it in action. I have set up everything again. I have removed my extension cable from there just to make it simpler. I have added the second adapter, and instead of the timer I have this switch. Actually I'm using this most of the time because this is just a simple switch. I can switch the charger on and off, and I can put the wires nicely away in my house, and I don't need to plug off and on the stuff. But when I want to use the timer, I will be able to plug it between the two in the winter or so. Now I have both adapters branching off from the mains input, and I have the charger connected to the delay relay, and I have the 12-volt adapter connected to the delay relay, and this is only powering the delay relay itself, which is a very low power consuming device. And the delay relay is switching the charger to the scooter without adding any active elements or load. So right now, if I'm turning the switch on, both charger is turning on. Actually, you can see that this is green and nothing happens. I'm not really sure why. I did not test it before making this video. So the relay should have turned on by now. Something is messed up inside, so those those screws will need to come off again. The problem was that one of the wires going into the delay relay was loose, so it did not get energized. So let's try again. 10, and you can see that the charger is green. 6, 5, 4, 3, 2. And the charger went red. I can see that the voltage is increased on the controller from 58 to 58.1. And this is how the charging is ongoing. When it is completely charged, it will go green, and delay relay will stay as it is, but sooner or later I will power off everything. Let me show you the process again. Turn it off. Everything powers down. Let me power it on again. We have the countdown. The scooter is protected from the voltage spike. And the charger is connected once more. And now I can have even a 2-hour delay here, because I can turn on the charger by a single switch anytime, and it will charge the scooter without giving that voltage spike to the scooter. That's all for now. Thank you for watching. Tell me in the comments what did you think, or if you have any ideas. And also, please don't do this for yourself if you're not sure. Messing with the charger is not a good idea if you are unsure of things, because you can burn down your house. This is a very powerful battery right here, and if you mess something up, that will not be happy. So be very careful. This was just my idea, and this is my my house. Don't take it as an advice for doing something really stupid. I'm just lazy and I like to automate things. So this is how the end product looks like installed in my home. This is how it works. Thank you for watching. See you later.